Welcome to your deep dive.
Oh, yeah.
Today, we're going to make you an analytics expert. Fast.
Fast, yeah.
We're diving into this presentation all about visual science informatics.
Huh?
And, oh my gosh, it is just like packed with ways to like really just slice and dice data
Yeah,
to get those juicy, juicy insights.
that's right.
So by the end of this deep dive, you are going to have a mental toolkit
A toolkit.
ready to tackle any data puzzle.
Ooh, data puzzles.
Yeah.
I like that.
It's going to be good.
So this presentation, it's kind of cool because it lays out a really clear, almost like a roadmap, for how all these different analytical methods kind of build on each other.
Okay.
And it starts with a simple question, which is,
Yeah.
what kind of analysis gets you the most value?
Ooh, good question.
And that's what they call the gold standard,
Oh.
which we'll get to as we go along.
I love a good treasure map.
Yeah.
So let's follow this one. The presentation kicks off with this visual breakdown of 6 core analysis types.
Yep.
And it's amazing how they just laid it out like a spectrum.
Yeah, it's beautiful.
Right. You start with the very basics, like descriptive analysis.
Huh.
And that's all about summarizing what the data tells us at a glance.
Right. Just like what's the average? What's the spread?
Yeah, exactly.
Key features.
Key features.
Yeah.
So it's kind of like if you have a messy room and you're organizing it.
Ooh.
You're not digging for those like hidden treasures just yet.
Yeah.
You're simply creating order.
You're answering the question, what happened?
Yeah.
Using good old-fashioned measures like mean, median, mode,
Yes.
standard deviation.
Yeah.
It's the foundation, like
Yeah.
the starting point
Yeah.
for any deeper dive.
Okay, so we tidied up the room.
Yeah.
Now what?
Now we're going to grab our magnifying glass.
Ooh, okay.
We're going into exploratory data analysis,
Oh, yeah.
or ED.
ED?
And this is where it gets really interesting.
Yeah.
This is where you're hunting for clues.
Ooh, clues.
You're looking for outliers,
Yeah.
trends,
Mm-hmm.
hidden gems in the data that might point to something unexpected.
It's like those hidden objects games, but with data.
Exactly. It's
Yeah.
like, where's Waldo? But for insights.
Uh-huh.
And a pioneer in this field was John Tukey.
Okay.
And he emphasized how crucial visual exploration is
Mm-hmm.
to avoid getting tricked by statistical noise.
Yeah.
He had this great example
Yeah.
where he had this data set,
Mhm.
and when he analyzed it statistically,
Yeah.
it looked like there was no correlation between these two variables.
Okay.
But then he plotted the data visually, and bam, a clear pattern emerged, which led to a major discovery.
Wait, so just by looking at the data differently, he uncovered something totally new.
Exactly. That's the power of ED.
That's amazing.
It helps us answer the question, what is unknown? Revealing patterns and relationships that traditional statistical methods might miss.
Yeah.
So it's going beyond just summarizing.
Okay.
And you're starting to ask why and how.
Oh, I'm officially hooked on E-Day.
Yeah, right.
But the presentation doesn't stop there.
No, there's more.
Next up, we have inferential analysis,
Okay.
which sounds a lot more serious.
A little more serious.
Yeah.
But it builds beautifully on what we've already learned.
Okay.
Here, you're taking a sample of data.
Yeah.
Imagine like a slice of a giant cake.
Oh, I like it.
Yeah.
Okay.
And you're using that to draw conclusions about the whole cake.
Okay.
This is where statistical models come into play,
Yeah.
helping us make educated guesses about a larger population
Right.
based on the piece we've tasted.
So it's like saying, okay, this bite of cake is delicious.
Yeah,
The whole thing must be amazing,
exactly.
but with a lot more statistical rigor, of course.
A little more rigor.
Yeah.
And by applying techniques like t-tests, we can answer the question, how did it happen? Okay. Testing specific ideas and starting to uncover the relationships within our data.
So we're moving beyond describing what happened to
Yeah.
starting to explain how it happened.
Exactly.
Pretty cool. But wait, there's more.
Oh, there's always more.
Predictive analysis
Okay.
or forecasting is next.
Forecasting, yeah.
And I'm guessing this is all about peeking into the future.
Got it. This is where we become like data fortune tellers.
Oof.
We're looking for like the crystal balls
Yeah.
hidden within the data,
Right.
patterns and relationships that can help us anticipate what might happen next.
So we're asking what might happen.
Yeah.
And trying to answer it by using really powerful tools like regression analysis
Yep.
and even machine learning to predict future trends.
Exactly. Think about how valuable that is.
Yeah.
Predicting customer behavior, forecasting stock prices,
Oh, yeah.
understanding disease outbreaks.
Right.
I mean, the possibilities are really endless.
Yeah.
And it all stems from the patterns we uncover in the data we already have.
Powerful stuff.
Right.
But the presentation takes it even further.
It does.
With prescriptive analysis.
Okay.
This sounds almost magical.
Yeah, like we have some kind of like data-driven GPS that not only tells you where you are, but it guides you to the best possible destination.
Ooh, okay.
It takes all those insights we've gathered from those previous analyses.
Right.
And it uses techniques like optimization, simulation to recommend the best course of action.
So it's not just about understanding what happened.
Right.
Or predicting what might happen, but actually suggesting what we should do about it.
You nailed it.
Okay.
So it's answering the question, what is the best course of action?
I'm definitely seeing the value here.
Right.
But I can't forget about that gold standard we mentioned earlier.
Yeah, the gold standard.
Causal analysis. What makes it so special?
Well, it's the pinnacle of analytical power because it goes beyond just correlations and it tries to really understand the why behind the data.
Okay.
So think about it like as a domino effect.
Right.
You see the last domino fall.
Yeah.
But causal analysis wants to trace back each domino like in the whole chain.
Right.
To figure out like which domino started it all.
So it's not just about knowing A and B are related, but understanding that A actually causes B.
Exactly.
Cool.
And to do this, we use powerful tools like root cause analysis, which helps us peel back the layers of data to pinpoint that primary cause of an event or problem.
It's like being a data detective, solving the ultimate mystery of why did it happen?
Yeah.
And understanding the why can be incredibly valuable.
Oh, yeah.
It can help us solve complex problems, make better decisions, and ultimately create a more impactful change.
Exactly. It's like instead of treating the symptoms, you address the root cause of a disease. You know, it leads to more effective and sustainable solutions in the long run.
So we journeyed through all 6 analysis types.
Yeah. We went on a little adventure.
From just describing the data to like really uncovering the why behind it.
Yeah.
It's amazing how they build on each other.
Right.
Each adding like this new layer of understanding.
Layers.
Yeah.
It's a pretty powerful framework, wouldn't you say?
Absolutely.
And the best part is that it gives you a clear roadmap for approaching any data challenge.
Yeah, absolutely.
So before we move on to part 2 of our deep dive, I want to leave our listeners with a question to ponder.
Okay.
Think about your own work or life. What kinds of questions are you trying to answer?
Yeah, good question.
And which of these analysis types could help you get those answers?
That's a great question to consider.
Right.
The world is full of data. And now you have the tools to unlock its secrets.
Ooh, secrets.
So take a moment to reflect on that.
Yep.
And we'll be back with part 2, where we'll explore some of these methods in even more detail.
That's right. More detail is coming.
See you then.
Bye. Welcome back to our deep dive.
Oh, it's good to be back.
I hope you've had some time to think about how all those different analytical approaches could like unlock insights.
Oh, yeah.
In your own world.
For sure. It feels like we've opened up this treasure chest of analytical tools.
It is a treasure chest.
But before we get too carried away, I'd love to unpack causal analysis a little bit more.
Yeah, let's do it.
It's the gold standard for a reason, right?
It is. It's the most powerful type of analysis because it helps us really understand that why behind the data, not just the what or the how.
Right.
And one key concept here is understanding these things called causal chains.
Causal chains.
Yeah, which can get a little tricky.
Okay, walk me through it. What is a causal chain exactly?
Imagine a company, right, and they launch this new product.
Okay.
Let's say there's a design flaw that causes the product to malfunction. So this leads to customer complaints, negative reviews online, and ultimately a big drop in sales, each of those events.
Yeah.
It's like a domino, tipping over the next one in this chain reaction.
So it's like a domino effect. Each domino represents like a cause and effect relationship.
Exactly.
And by tracing them back, we can pinpoint that very first domino that started that whole chain reaction.
Precisely. That's where root cause analysis, or RCA, comes in.
RCA.
Yeah. It's a systematic process for really identifying the root cause of a problem.
Okay.
By working backward through that whole chain of events.
So in our example, RCA would help us identify that initial design flaw
Right.
as the root cause of that sales slump.
Exactly.
And by fixing that flaw, we can prevent that whole chain reaction from happening again.
You got it. Causal analysis allows us to go beyond just reacting to problems.
Right.
We can proactively address their root causes.
Yeah.
It's all about understanding that why, so we can come up with lasting solutions.
This is really making me think about all sorts of scenarios where understanding causal chains could be so helpful.
Yeah, for sure.
But I also realize that these analytical methods aren't really meant to be used in isolation, are they?
That's a great point. They actually often work best in combination,
Okay.
complementing each other to paint this richer, more comprehensive picture.
Yeah.
It's kind of like using different lenses to examine a specimen under a microscope.
Okay.
Each lens reveals these unique details
Uh-huh.
that all contribute to the overall understanding.
I like that analogy.
Right.
So you might start with like descriptive analysis
Yeah.
to get that basic overview,
Uh-huh.
then use EDA
Yeah.
to explore those interesting patterns or outliers.
Right.
And then from there, you could use inferential analysis
Yeah.
to test hypotheses and draw conclusions about a larger population.
Exactly. And if you need to like anticipate future trends or outcomes,
Right.
predictive analysis would come into play.
Right.
But if you're dealing with some complex problem that requires a deep understanding of like the underlying causes,
Yeah.
then causal analysis is going to be your go-to tool.
It's about choosing the right tool for the job.
Right.
And often that means using a combination of approaches to really get the most complete understanding.
Exactly. It's like
Yeah.
having this whole toolkit
Yeah.
of analytical methods at your disposal.
Ooh, a whole toolkit. I like it.
And like any craftsman,
Right.
the more you practice with those tools,
Yeah.
the more skilled you'll become at using them effectively.
Sure.
And this field is constantly evolving
Yeah.
with new technologies and techniques, so it's really an exciting journey of continuous learning.
That's what makes it so fascinating.
Yeah,
It's not just about crunching numbers. It's about thinking critically and creatively to solve real-world problems.
for sure it is.
But speaking of problem solving,
Okay.
I think it's worth emphasizing that the most important step in any analysis is really clearly defining the question that you're trying to answer.
It's like setting off on a journey without a destination in mind.
All right.
You might end up somewhere interesting,
Right.
but it's unlikely to be where you actually need to be.
Yeah.
So clearly defining that question helps you choose the right path
Right.
and focus your analytical efforts.
So before you even start gathering data,
Yeah.
you got to ask yourself, what am I trying to learn?
Exactly.
What insights do I need to actually make a decision or take action?
That's the key.
Okay, so define the question, assess the data. What's the next step in choosing the right approach?
So think about the level of insight that you need.
Okay.
Do you need like a simple descriptive overview,
Mm-hmm.
or are you looking for like deeper, more causal explanations?
Okay.
Are you trying to understand past events
Right.
or predict future trends
Mm-hmm.
or recommend the best course of action?
Right, so the level of insight you need will determine the complexity of the analysis required.
Exactly.
If you just need a quick snapshot of what's happening.
Yeah.
Descriptive analysis might be enough.
Right.
But if you're dealing with like a really complex issue
Yeah.
that demands this deeper dive
Right.
into the root causes,
Yeah.
then causal analysis might be necessary.
Precisely. And don't be afraid to experiment with different approaches,
Okay.
because sometimes the most insightful results come from combining those methods or even looking at the data from different angles.
Ah,
It's all about finding that approach that best illuminates those answers.
right. That's such a great point.
Yeah.
And it really highlights that data analysis
Uh-huh.
is as much an art
It is an art.
as it is a science.
It is.
It requires critical thinking, creativity,
Uh-huh.
and a willingness to try different approaches
Exactly.
until you find the one that works best.
It's like learning to play a musical instrument. The more you practice,
Uh-huh.
the more you develop your ear and your ability to create beautiful music.
I love that analogy.
Right.
So we've talked about all the different types of analysis, the importance of choosing the right approach,
Uh-huh.
the need for a clear question and reliable data.
Right. We've explored causal chains using root cause analysis to uncover those hidden drivers and combining different methods to really get that richer understanding.
It's been a fascinating journey so far.
Oh, yeah.
I'm feeling so empowered to tackle any data challenge that comes my way.
I love that.
But before we wrap up part 2,
Yeah.
I want to leave our listeners with a question.
Okay. I love a good question.
It might spark some further reflection.
Okay. What is it?
We've discussed the power of analytics.
Yeah.
But it's equally important to be aware of the potential pitfalls.
Oh, that's a good point.
So here's the question. What are some common mistakes or biases
Biases.
to watch out for when you're conducting data analysis?
Okay.
We'll dive into that discussion in part 3 of our deep dive.
That's an excellent point. To ponder, data can be incredibly revealing.
Yeah.
But it can also be misleading if we're not careful.
That's true.
So join us in part 3 as we explore those potential pitfalls.
Okay.
And how to avoid them.
Welcome back to the final part of our deep dive.
Oh, yeah. The grand finale.
We've explored this amazing world of analytics.
Yeah, we've been on quite a journey.
From those basic descriptions to uncovering those hidden causal chains.
It's been fun.
But like any powerful tool, analytics can be, misused.
For sure.
So today we're getting into the danger zone.
Oh, the danger zone.
The common pitfalls and how to avoid them.
Okay, I like it.
It's kind of like learning to drive, right?
Okay.
You need to know the rules of the road, how to handle the car,
right?
But also what to do if you hit a patch of ice. Data can be slippery like that.
It can.
And we don't want you spinning out of control.
It's no spin out.
So what's the first hazard we need to watch out for?
Let's talk about confirmation bias.
Okay, confirmation bias.
Yeah, it's that sneaky tendency we all have to favor information. That supports our existing beliefs.
Yeah.
Even if the evidence is kind of shaky.
Oh, yeah?
We might cherry pick data points or downplay anything that contradicts our, pet theory.
Oh, I've definitely been guilty of that.
Yeah, me too.
Especially if I've put a lot of work into it.
It's so easy to get attached to an idea.
Right.
Absolutely. It's human nature.
Yeah.
But in data analysis, this can be really dangerous because it can lead us down the wrong path.
Yeah.
So the key is to be aware of this bias.
Okay.
And to actively seek out diverse perspectives.
So challenge your assumptions.
Exactly.
Look for evidence that might disprove your hypothesis.
Yeah.
Be open to changing your mind.
It's about being a data detective.
Yeah.
But also being open to the possibility that the suspect you're, focused on might actually be innocent.
I like that.
Right.
Okay, so what's another pitfall we should watch out for?
Well, selection bias.
Selection bias.
This happens when the data you're analyzing isn't really representative of the group you're actually trying to understand.
Right.
Imagine trying to predict election results.
Yeah.
But you only survey people at a political rally.
Oh, yeah.
Your conclusions are going to be,
Little skewed.
very skewed.
Right.
So your sample needs to reflect the diversity of that whole population.
Right.
Otherwise, you're going to end up with misleading insights.
So how can you avoid this?
You got to scrutinize your data sources.
Boy.
Ask how the data was collected.
Yeah.
What groups might be overrepresented or underrepresented.
Right.
And if there are any inherent biases in that sampling method.
So it's not just about the data itself,
Right.
but also understanding the context in
Exactly.
which it was collected.
Yeah.
That makes sense.
Now, one more bias that we really got to watch out for is this thing called the availability heuristic.
Availability heuristic.
Yeah. And this is where we tend to overestimate the likelihood of events that are easily recalled or emotionally charged.
Right.
So think about plane crashes.
Okay.
Statistically, they're very rare.
Yeah.
But because they're so vivid and widely reported,
Right.
we might perceive them as more common than they actually are.
Oh, I see.
Right.
So if we're not careful, those dramatic or memorable events can really warp our perception of reality
They can.
and lead to some faulty conclusions.
Big time.
So how do we avoid falling for that?
You got to be critical of your data sources
Okay.
and look for objective evidence.
So don't rely solely on your gut feeling
No gut feelings.
or anecdotal stories.
Not just stories. You got to dig into the data.
Wow.
Look for those patterns and trends and always ground your conclusions in solid facts and statistics.
It's like that saying, in God we trust, all others must bring data.
I like that.
We need to be data driven,
Yeah.
but also data savvy.
Data savvy. That's it.
Right.
So those are just a few examples of the many biases
Yeah.
that can kind of creep into our analysis.
Yeah.
Our brains are wired to take shortcuts, but those shortcuts can sometimes lead us astray.
That's true.
So the key is to be aware of those pitfalls and to develop strategies to really mitigate them.
This has been such a fascinating deep dive into this world of analytics.
It really has.
We've covered so much.
Yeah, we have.
From understanding those different methods to recognizing the potential pitfalls.
Right, all those tricky biases.
Feels like we've earned our data analyst badges.
We have. We've leveled up.
So keep exploring.
Yeah, keep learning.
Keep questioning.
And always, always be mindful of those slippery biases.
Until next time.
See you then.